automated response is that, oh, I would never do that, right? I want to be in control of my system. I want to, be able to decide what happens and what type of response I take, and I don't trust a machine to do that for me. And I think those are some fair assessments. So what we wanted to do is give you a talk today about different ways that you can apply automation. And there's lots of different forms of automation, and we're going to go through those. So my name is Chris Blavelt. I'm an electrical engineer by training. I spent 10 years in power generation before coming to Fortinet, where I've been for 3 years now. Carlos Sanchez spent how many years in oil and gas? 15 years in oil and gas before coming to Fortinet. He's been with Fortinet for more than a couple years. And Nathan Dan has been in process automation, automation networking for several years. So we're going to talk to you today about how we can apply different types of automation and what that means. And so what we're going to be doing is talking about the engineering processes that give you reliable automation, give you reliable situational awareness, and some of the things that you can do to increase the amount of response time that you have. Essentially moving from the I'm under an attack and things are shutting down within my plant to, hey, something's not right here, let's investigate. And so we have two scenarios. Like I said, I come from power generation, so I spent some time doing reliability engineering. And so, here are two situations where we need intervention, right? One is a fault occurring on an electrical line requiring a breaker trip. When you interconnect with a large transmission owner, you are told if you have a fault within your system, you have 125 milliseconds to trip, right? And you have to backwards plan that. And what you usually end up with is you have 1 or 2 cycles, which in North America is 1632 milliseconds, to be able to trip, right? Including breaker operation. That is obviously well beyond the ability of a human to make a decision, right? So we have engineered systems for that, okay? Now, another scenario that we have, sometimes as a result of scenario 1, is we have a transmission line that ends up carrying 110% of capacity. Maybe some generation dropped out. This is an acceptable situation. We've planned for this, and we know that we can run in this situation for at least 30 minutes. After 30 minutes, we're going to start causing damage to the line. You're going to get droop in the conductors. You're going to damage those conductors. And so when we are planning for reliability in the electrical grid, we have different contingencies. We had the N-1, which means one thing goes wrong, right? Maybe you have a line to ground fault and you have to take out part of your system, right? Why are you taking out part of your system? Resiliency, right? You want the rest of the system to be able to survive so you can continue to provide electrical service to your customers. There's the N-2, which is a double failure. Maybe you have one pole with 2 electrical lines on it. Maybe something happens that causes 2 current carrying paths to fail. And then we have the N-1, which does not equal N-2, all right? Don't try to do math here. What this means is I have a failure, I respond to the failure, and then I have another failure in an unrelated system, right? So that's generally the degree of planning that we go to in a transmission electrical grid to be able to understand the impacts of failure. And so what are those N-1 or N-1 contingencies? We look at every device, every single device within the electrical grid. And we say, what would happen if that failed? Okay. This is the kind of engineering that you can do, right? Now, electrical grid, cost is not usually a factor. In most other industries, cost is always a factor, right? So there's different trade-offs that we have here. So you might decide that a certain system failing and the subsequent amount of your capacity that comes offline is acceptable, right? You might decide that your HMI that's running Windows XP has malware on it, and you're going to take considerations to allow that to continue to run with malware on it for the next 6 months because that's when your next scheduled shutdown is, right? These are corollaries that we can draw to things like manufacturing or other industries that we have. And so what are some of the fundamentals of automated response? When we talk about reliability and systems operating automatically, what do we mean? In power, we talk about dependability, which means it operates correctly when it's supposed to operate. We talk about security, which I understand is confusing in this context. But security, what that means here, is it does not operate when it's not supposed to, right? It sounds obvious, but again, we're talking about fundamentals here. Then we talk about specificity. I don't take down the entire state of Florida because I had a fault on one line, right? That happened in 2003, and we didn't like it. So we designed around it, right? So what does that look like from a cybersecurity context? I have a malicious process running on an endpoint. Do I shut down the whole endpoint? Can I maybe just shut down that process, right? And continue to operate? What are my risk calculations? And that's going to be different for everybody. And so what are some of the levels of automation? I think, maybe not in this room because we're all at a security conference, but a lot of our customers are coming to us at level 0, right? They have no information, no automation. That's your typical flat network. You're not seeing what's going on, and you wouldn't be able to do something about it if you did get attacked. And so then we move on to passive monitoring, which is the alarms, right? We're getting information. We have to manually process, manually triage these alarms to determine if there's an issue. Then we get into monitoring, alarms, and recommendations. This thing has happened. I recommend that you do X, Y, Z, right? What does that look like in the security context? That might be a playbook that you already have set up in some type of system where you can, something happens, you open the playbook and you execute the steps, right? Maybe you don't have an automated platform, but you have an SOP, right? You have a checklist. By the way, big fan of checklists. If you're not generating checklists, when in the heat of the moment, you will definitely wish you had them, okay? There are automated platforms, we call them SOAR in cybersecurity. That is essentially a way to automate that checklist. You can do the next step, click next, next, next. Okay. So the next thing is the person in the middle automated response. We do this in the military. Before I was in power generation, I was in artillery, and we would monitor for incoming fire. And then we would shoot back, right? We have the capability to automatically shoot back at whatever's shooting at us. But we don't. Why? Because it's a policy in the US Department of Defense that there will always be a person in the middle deciding when to launch kinetic weapons. Okay? So, what does this look like from a cybersecurity perspective? I have an event. I have maybe fully automatically taken some action. I have stopped an endpoint or stopped a process on an endpoint. Now I am recommending that you take a look at these 5 endpoints because my data tells me that there's indicators of compromise based on this malware that I have seen. And then you have the fully automated response. I have not seen anybody do this. We were talking to a vendor, an OEM, and came up with an example of what fully automated would look like. I have a DCS system that has 2 HA controllers. My primary gets compromised. I recognize that, kick over to my secondary, and quarantine the primary. and I prevent that secondary from talking to anything that's not a part of its DCS system, right? That's just an example of where some of the OEMs are looking to move to. So how do we use automation to improve situational awareness? We know people are not good at passively monitoring information for a long period of time. That's what you get with alarm fatigue, right? Maybe it's a false alarm that you're always getting, and when it does come in and it's actually right, you don't know or you don't care, right? As we start to increase the complexity of these systems, the aim is always to decrease the complexity for the operator. Sometimes that means decreasing or increasing the complexity for the maintainer. It's a lot harder to drive a Model T than a Tesla. It's a lot harder to fix a Tesla than a Model T, right? And so what are some factors in operator responsiveness, right? We're talking about trying to give you more response time, but how do we improve your ability to respond? And so when we look at the data that we have, right? If we have high fidelity, low fidelity data, we have high confidence and low confidence. What are some things that would cause low confidence? A commonly failed alarm, right? Or a false alarm. What are some examples of people operating with bad data, but they have high confidence in it? If you read the after-action reviews of the 3 Mile Island disaster, that's exactly what that was, is they had bad data, but they had high confidence in that data. Now, here's something to remember that in an industrial process you don't always have, right? The designers are continuously trying to give you better confidence. In a cyber attack, your adversary is always trying to reduce the level of fidelity and give you high confidence in it, right? And so these are the different columns. If you look at the MITRE attack for ICS, these are the different actions that you go from initial access to impact, right? And as you move to the right, you're going to have less response time, less fidelity, right? A breaker operating is a very violent response to an issue, right? You might have similar violent responses in your safety systems, right? So the idea is that we want to move ourselves back to the left, catch things earlier, catch things that give us more ability to respond in a control-managed manner, right? And so this is partially defense in depth. When I talk about N-1-1, that's your antivirus doesn't catch something coming in, but your EDR does. That is, your physical security guy clicking yes, log in, but then something else on the network is able to detect malicious behavior, right? That's your N-1-1. We call it defense in depth, okay? And so what we're going to look at is different ways that we can move things to the left, improve our situational awareness, and give ourselves the ability to respond in a timely manner to cyber attacks.
One of the constants that we saw during that presentation, at the beginning of the presentation, is time. And we all have time, right? I mean, we all have time to waste. Hell no. Time means money. So what we're trying to do here is create the quickest response, the fastest response, while maintaining safety and efficiency. That is the important thing for us. So how do we do that? How do we do that? Because again, some of the stuff that you see on the screen, you have seen before. But let's put this in a context that makes more sense to us. Sons and conduits, secure remote connectivity, deep OT visibility, role-based access controls, SOC and NOC, and advanced threat protection or advanced persistent threat. That is something that we need to look at. In reality, to defend all this and to translate security, efficiency, and resiliency into terms that can be controlled, that can be reduced in time, we need to work on those 4 little boxes in the middle. In fact, let's do the first 3. Let's forget about the last one on the right. The first thing is visibility. We need to have visibility of traffic. We need to have visibility of devices. We need to have visibility of all these cool devices that we have that affect the power plant. Detection, identification. And I know, I mean, in new terms, IIoT and IoT, that is really important. But when you think about it, if you can see it, you can protect it. That's where it starts, with visibility. And we're gonna make a little bit of a distinction between visibility and visualization, because the term visualization, for us, visibility, or for most people, visibility is being able to see the traffic. Some other people think of a topology map, and I think that they're both, I mean, valid definitions. But the reality is, when we're talking visibility, the way I like it is, you have Google Maps and you have your windshield. If you have visibility, you know that you can turn left and right. You see the threat, you see what's going on. Google Maps is great, right? You have visualization. It gives you a really cool map as to where to go. Will you trust it to drive your car without your intervention? I guess it depends. If you have a Tesla and you bought the $12,000, I mean, autopilot, maybe you do, I don't know. But the reality is that we need to have visibility to make those decisions. And to follow up on what Chris said, that man in the middle. We need to have that visibility to make accurate decisions. If we can see it, meaning, and we're talking in cybersecurity terms, if we can see it, we can control it. Control, the four basic functions of any cybersecurity system. We monitor, we block, we allow, or we quarantine. That's that. Every cybersecurity system can be boiled down to those four basic concepts. That's what we do. But monitor is really important, because monitor is going to take us to the next one, intelligence. And if you like me, I mean, I've been around the security field for quite some time, you know that there are so many freaking sources of data. And to Chris's comment, I always say that, right? I mean, people that work in SOX and NOX and whatever the operation, I mean, security operation you have in your industry is called, I mean, they can get jaded. Because really, the volume of alarms, if they're not properly correlated and assigned some level of intelligence, it's like I say, I'm ignorant and apathetic, I don't know and I don't care. So the same thing will happen there. So bringing some intelligence, some degree of correlation that we can get those sources of data and create something that makes sense to the business and reduce the risk, that's really important. That will lead us to automated response. And in that part about automated response, that in our business, I mean, that sometimes that's like a four-letter word. How much automation, automated reaction do we have of a particular condition using IT systems? Because ultimately, even if they're OT, I mean, they started in IT. I mean, that's where everything started. So those systems, I mean, how much do we allow them to respond automatically? To do that, we need data fidelity. We need to have our processes properly mapped. Like Chris said, creating proper templates. And again, you cannot automate a process that you have not properly mapped. There's companies that spend millions of dollars automating something that they don't even know they have or they don't need. So that is foundational. And the last thing is advanced threat protection. I think it's backwards. But using deception technologies and leveraging artificial intelligence. And again, when we're looking at the maturity of companies or the maturity of our processes, we might be in a position as a business that we allow, decisions to be made by artificial intelligence. We might include some deception technologies, but this is all contingent on how much risk it brings to the business. What is your risk tolerance? In order to see things, these are some of the protocols that we deal with all the time. And to be brutally honest, you probably identify one or two, like myself. I mean, I've been doing this for 36 years. So you might see protocols like Modbus and all that, but what does that mean in terms of, let me get out of your way here so you can get a picture and we can share this with you guys at a later time. But what does this mean, having visibility of all these protocols and applications and all that? Because this is foundational in terms of having visibility inside of the packet and making those decisions. What does that look like for us? If we do deep packet inspection on a Modbus string, we're looking at categories like, what happens if I see that string of 01010101 and then 008? What does that mean? In the past, there were some CVEs that will take a PLC and will send it back to factory default. Well, if you have that in your environment, and you know that that is happening, now you have the power, because you have the visibility, to whitelist your traffic and say, when I see the 0101010100A, then I can say, not only no, but hell no, you're not going across. So ultimately, what you have done, if you whitelist it, and this can be done at a massive, at a larger, I'm not going to say massive scale because that's kind of scary, but at a larger scale, that you can bring it down to only the traffic that needs to be on your network. That's the traffic that you allow. And we can do that because all of us are looking at, we have some of those bad boys in our environment. So we can get to this point that we only allow what needs to be allowed. So here we go about visibility, because this is a graphical representation of a network. And it's important to us because, yeah, we are visual people. I know, I'm a mathematician by profession, and I like numbers. I love my numbers, but there's a lot of people that prefer something of this nature. So that visibility can also be visualized. And that level of visualizations will allow us to make decisions based on that, because then you can go into the 3 typical conditions, right? I mean, that we see in a map of this nature. Green is good, yellow is maybe, red is bad. There's some people that define that, that work on those terms. And honestly, when you look at your sock and knock and you get that first line of defense, that might be a human that is looking at a gigantic screen. Maybe when they get to yellow and red, you want them to jump. So we want to not only have the visibility at the engineering level, because let's call it a spade. When you start looking at registering what goes across, you're making decisions, that are engineering related, because you have to engineer traffic. It's traffic management. But that has a lot of value as well. In addition to that, if we start looking at the traffic and doing deep packet inspection, it will behoove us to have, oops, did it go back? Oh, all right. Jumping back and forth. Indicators of compromise. So for us, we can whitelist a network till we're blue in the face, but let's leverage the intelligence that we get from our providers. This is really important because it keeps going back and forth for some reason. But let's go back to the indicators of compromise. All right, if it jumps one more time, I want to skip it. This is starting to become annoying. Anyway, like the guy that invented the cereal, thanks for nothing. So when we're looking at the indicators of compromise, that can lead us to automation as well. So that's what we're looking at. And at the end, the question that we'll have to answer here is, how much automated response are we going to have at the end of the day? Myself, I say that we're in a transition period where we are embracing automated response and less human intervention. I think as those of us that have been doing this for quite some time, we leave the business, it's going to be inversely proportional. The less of us that are around, there's going to be more automation. And we can go into an entirely different beer discussion as to what is it that, the expertise is living the field, and we need more people to embrace the technology and get in this one. So anyway, some things for visibility. When we start structuring our network, structuring our environments, these are some of the models, that we follow, architecture models that we recommend for visibility concerns. IEC 6243 and the Purdue model that will give you a good tiering of your environment. Is this gospel? No, it's not. This is the North Star. You might not need all these levels of division. However, it's good to know that if we need to isolate a particular threat, again, microsegmentation, and we talk about that as well, when we start reducing our collision domains into some manageable chunks, we look at microsegmentation as a proactive approach to mitigating threats. So that's one of the things that this allows us to do, because at this point we see it in a vertical way, right? And we get it from the plant all the way up, and we can segment at that level. We can segment at level 2, layer 2 OSI, that's one thing that we do. But if we go back a couple of slides and we go look at that Modbus breakdown, now we're looking at layer 7 OSI, which will allow you to do microsegmentation based on application. And that's a really powerful tool. Because for all of us that have an engineering mind, that means that I can create segmentation based on whatever comes or define it by software, or as they call, software defined, right? What does this segmentation look like? This is just an example. Please don't go out if you don't have this on your environment, run out and say, oh crap, we got to hire people. But in the end, when we start correlating automation, we start correlating defense in depth and visibility, we have to look at all those conduits. We need, look at high availability. We need to look at all those concepts that will take us to not only defense in depth, but resiliency and reliability. I skip on that one because I like to talk about automatic microsegmentation. And let's forget about brands and forget about everything. Let's talk about conceptually what this means. When we talk microsegmentation, a lot of us, they take 2 steps back and say, man, that's a lot of work. I always say, give it to the laziest guy in the room and he'll figure out how to make it easy. When we start looking at this and we start looking at technologies like network access control, and we do device identification at layer 2 OSI, the moment that there is a link state change on the device, then we can say, oh crap, there is a Siemens PLC. I recognize it as a Siemens PLC. I'm gonna move into my VLAN 300, and upstream on the firewall, regardless of your vendor, you have a policy, you have a security treatment that will say whatever comes on that device on VLAN 300, I'm gonna allow, I'm gonna decline, I'm gonna deny, I'm gonna quarantine, I'm gonna monitor. So you have that device, plug it into your network. It will put it in the proper VLAN. It will apply a security treatment, and you effectively have segmented your network from layer 2 to layer 7 with very little touch. So what does that mean in common terms, right? What does that mean to us? Is going back to that point that we want to reduce our collision domains, so we have, as a proactive approach to response. So that's one thing that we're doing. And of course, this example is really rudimentary when we look at it. 100, put a Siemens, Schneider go to 200, the 100 ABVs, go to 100. And then you got one that Click PLC. So Click PLC, we don't know what it is. It's not allowed by our business. It's not one of the ones that pass change control and all the mechanisms that we have to allow things in our network. And we isolate that guy. Notice that I say isolate, I didn't say block it. Going back to the discussion before in the levels of readiness, maybe we need a human to ratify that thing either needs to be there or doesn't. So the decision is ultimately yours. It's made by a human. Do we have a great appetite for automation? Again, that goes with the risk to the business and is determined by you guys, by the business rules.
How's everybody doing today? So my colleagues tend to be a little bit more long-winded than I am. So I have a very simple kind of example for you here. And real kind of case here, what this looks like. Again, very simple. My background is extensively in the OT environment. And we like to keep things, as Chris says, checklist, first of all, and things really simple to understand. So if you're in one of our earlier sessions, the gentleman stood up and talked about how he was able to penetrate using phishing, right? So it was Food Truck Friday, sends an email out to the organization, targeting folks saying, hey, click this link, place your Food Truck Friday a little early, place your order, and then he's off and running, right? So Bob, our gentleman Bob, clicks that link. Here he goes. So now what you'll see is that the natural sort of flow, right? It goes over to your firewall. Our firewall gives some a little bit of intelligence to it, says, hey, this looks like this is introducing malware. Now what? Well, it's blocked. And as you see it kind of go down the train, and what we're doing here is we're combining simple log management and security analytics. So we have this phishing attack. We've seen what's happening. We block it. We identify that it's a phishing attack, okay? Now we're analyzing it and we're sending it up to IT to do further investigation. Do I need to quarantine it? Can this all happen automatically? Is there a man in the middle that needs to click a button? All of these possibilities are at your fingertips as long as you start taking these things into granted. So again, very simple example, shows you sort of how this will flow, and then give you a little visualization on what this might look like. So here's a simple SOC environment. You have what we've identified as possible incidents. So now your folks, and again, we always talk, and a lot of these is not having enough people, not having enough folks with the abilities to take care of these things on themselves, right? So now we're automating this process. We've recognized that maybe there's some incidents out there that need to be taken care of. You click through and bingo, your operators or whoever has a playbook now to address the situation, okay? Sounds really, really easy, but again, we've built all of this out. I think we've all done things where we've done a process, and sometimes it's very complicated, sometimes it's very simple. Then we have to go back to it 3 months later and go, oh, I remember how to do this. No, I don't really remember how to do this. And you start back at step one. So what you're doing here is effectively eliminating your time to respond, or at least lowering your time to respond significantly. Again, maybe in this case, right, we've already built the playbook, but if you go back to our other screen, we see the visualization. Maybe this is where the playbook needs to be created because it's something that's been recognized as maybe a new threat to the environment. So again, all of these things automatically automated. You click through, you get a playbook, you're off and running to responding, or doing the other steps that you need to do. Do we need to further quarantine? Do we need to now take a look back into these logs and do a little forensic analysis and say, what happened? Where are we at? Did anything else change? Maybe you can even identify what they're going after. But again, it's just using simple tools. Again, log management's nothing new to the industry. Security analyzing is not new to the industry, but when you combine the two and you start looking at these things and as they correlate, then you start getting some really powerful solutions and ways to address these things.
Show of hands, how many of you guys have seen a hack, taking place? That cat, you probably did it because you were the first one to raise your hand. So you were probably the guy. One of the things that we see in hacks is it's not really a proper term for what happens when there's an intrusion. I will say that there are some times that we're looking at perhaps poorly written code. We're perhaps looking at inadvertently somebody brings a dirty device inside, or there's plain Jane, somebody that comes with malicious intent from the inside. So we know the MITRE framework. We know what we're looking at. Engage in this part of the cyber kill chain. But one of the things that the deception technologies allow us to do is how do we deal with the insider threat? Even on the outside, because frankly, in the years that I've been doing this, I've seen external attacks or external hacks about 3-4 times in my entire career. And they were mostly done in the government, so that was a different story. Anyway, but what the deception technologies relative to the MITRE framework attempt to do is to create a decoy. And a decoy that me, as a Mr. Bad Guy, gonna see it, and it's gonna show perhaps as a fully unprotected PLC. And I'm gonna go after that PLC. And I'll give you one of the ways that we used to address security issues in the government, as a matter of fact. And most hackers, the way that they go about finding their targets is that they create a fire, what we call a trash can fire. And a trash can fire is nothing but I'm gonna go and create and do one action that is gonna force you to react outside of the boundaries of what you're used to doing. So at that point, you go, let's say for instance that we try to compromise an NT server or a Windows server of whatever AD or something of that nature, and you run. I'm looking at what you're gonna do. And based on that, I will design the real attack. Well, I'm sorry, they will design the real attack. Now, if you come up with a lure that will take me to that place, and I will go after that device, and then that device will communicate efficiently with the rest of my security infrastructure, well, I'm probably gonna look like a dumbass. That's what we're trying to do. That's what deception technologies do, is lure the attacker into a position that it can be mitigated and it can create a fast response. Let's not call it automated, because again, automation can be a 4-letter word still. Why do we recommend deception? It reduces the risk. Frankly, I know on the tactical side, yeah, it's fast response, but on the strategic side of deception technologies, we're looking at, they are future-proofing our network. We're future-proofing our investment, because again, let's go back to square number one when we were talking about time. Time is money. We are looking here that by all this automation, all this concerted effort, of all these technologies that we have together, it's going to reduce the time to response. If it reduces the time to response, I mean, you don't have to deal with forensics, you don't have to deal with all that stuff, which means that you'll become a more efficient operation. And in our business, I mean, that efficiency can be directly translated to safety and efficiency. Safety, well, I don't have to tell you guys what safety does for our business. And of course, efficiency, because we want to get the most of our FTEs. So here we go. Adding deception technologies. Again, I'm not going to say that this is the North Star. However, it's a really good technology to include because frankly, most of the attackers, they don't expect to see this. How do we correlate all this stuff? Security information and event management. We have a gazillion sources of data, and going back to the alert fatigue, the I don't know and I don't care. That's what we're trying to avoid. We're trying to avoid I don't know and I don't care. So we're going to take that information and we're going to put it in a way that it can be first based on that MITRE attack framework, but also that we can correlate it and add all those sources of information in a way that it can be expressed in meaningful dashboards that go back and correlate to the SOAR or the response dashboards. Now, when we start, and I'm sorry, I'm running out of time, so I'm going really fast on this. When we're looking at, in terms of what we do, we talk about that framework, the IEC 62443 and the Purdue model. If we can present those alarms and those conditions in a way that correlates to that model that is tiered from the operation all the way down to the in between IT and OT, we're saving ourselves a lot of time. It makes it a lot more efficient. Anyway, all right. Thank you for your time, guys. I think that we are on time here. Any questions so far? Mr. Blavel, will you please, come on up.
Yeah, any questions? Yeah.
So, I don't know how to ask this question. Since you mentioned defense in depth, my question is, how feasible is it to air gap all the critical systems, bring them online on demand, do the backup, software updates, and then air gap them again?
That seems that seems enormously complex. I know we do that in certain industries. Nuclear power comes to mind. When we're doing updates, maybe we, sneaker net updates across that air gap. I think that's why generally we don't find air gaps in industry at this point. It can be done. It's a lot to manage. Certainly important to mind your maintenance windows, whatever those may be, and also equally important to ensure that air gap, once reestablished, stays established. That gets into your visibility, right? Can you, if I start seeing Modbus occur between two links that I'm not used to, or some other thing that I have identified as a Rockwell Automation PLC, that's a pretty good indication that my air gap was not kept, right? And so if you're going to do that, I'd say the benefits aren't really great to doing that, but if you are going to do that, make sure you're monitoring your network to make sure that your air gap actually is.
If you guys want to break the air gap, or you want to test your air gap, if you think that is, we used to call it security by obscurity, but that line is disappearing. It's becoming kind of shady. If you want to test your air gap, block Instagram and Facebook and all the social media, and you're going to see if you're really air gap or not, because somebody's going to figure out a way to jump across. And that's one of the things that going back to visibility. Because what we're looking at is, we want to preserve, I know for some businesses that they need to be air gap, need to be separated because they're regulated. However, for us it's constant security posture assessment. And in there, and I can tell you from my own experience that I have seen that where we block everything and all of a sudden you see somebody trying to get into Instagram. So there is constant assessment, security assessment, consistent. Any other questions? Are there still lunch out there? and hungry.
If I can just add something, oh yeah, please go ahead.
So you were describing a PLC or system that everybody's going to go as a priority to. Is it like a honeypot or something?
So the deception, yeah. So what is
my
yeah.
question is, how do you make it look to the hacker that it's important?
How do you make it not look like a honeypot? Yeah, no, that's a really important question. Let's get into what the difference is, though, first. Deception and honeypot. So the honeypot is the device that's sitting out there, right? The difference between deception and honeypots is the lures, right? Having those lures that are out there. And so we talked about the PLC example. We've had some customers that actually integrate the deceptor into their SCADA system. So their SCADA system is pulling it for data. That's how you make it look important. We also have some honeypots that are a Windows XP machine, right? You're probably going to find those on a manufacturing floor or power generation, water, whatever you have, right? You put credentials onto an engineer's machine for that Windows XP machine. Those engineers get compromised. They try to use those credentials. You have a problem, right? And the point of all of this is that it's extremely low false positive, right? We're talking about that fidelity of data and the confidence of the data. Maybe you have a SCADA engineer that's about to have a really bad day, but more than likely you have an adversary in your network that's poking around. And so that's how we move ourselves back to the left on that MITRE attack framework, right? Integrate it with your systems. Put credentials out there for people to find. Place these things out there for people to find whether or not they're doing a massive scam. Yeah.
I know I'm between you and your lunch, so please bear with me for a second. You had an example where you showed a SCADA system and then the interaction from the SCADA system to various PLCs and how you provide that level of security so that you know exactly who is talking or you can identify yourself. But beyond that system, right? I mean, if you look at factory networks, it's not just the SCADA, it's your different databases, it's also the cloud. So how do you make sure that from an end-to-end perspective, you have that same level of security, right? Outside of the example that you provided.
Really good question, and I'm glad that you brought the four-letter word cloud. It used to be that our compute was limited to a data center, and now we know, again, to what Chris said, resiliency, redundancy, all those factors come into place. So the deal, to us, is having a uniform operating system and security posture that is the same on a physical appliance, private cloud, and public cloud. And at that point, you can design a system that is the same, and the user experience remains the same. Because honestly, at the end, if they don't know that they're running on the cloud, they're running on the cloud, right? However, what is our responsibility to make it secure, make it efficient, make it safe? Because and 80% of the time, definitely, going back to the lures and deception technologies and all that, if we can translate that and take it in, basically make it ubiquitous, that nobody knows where they're at, make it redundant, it's really important. And about 75% of the time, statistics are made up on the spot, so I made up that deal, that 80%, so that's okay. But no, all joke aside, it is the fact that having a operating system, a system that all the security components, look the same, and if it's the physical plane as they do in the virtual plane, that is really important.
Okay.
Bueller.
Are we wrapped up now, or we have any more questions, or? He's one of us. All right. So are there any more questions? Okay.
Yeah.
Fortinet team, thank you very much. Great job.